A gas turbine is supplied with gas at 5 bar and 1000 Kelvin and expands it adiabatically to 1 bar. The mean specific heat at constant pressure and constant volume are 1.0425 kilojoule per kg Kelvin and 0.7662 kilojoule per kg Kelvin respectively. What is the power developed in kilowatt per kg of gas? Here, in the gas turbine, expansion process follows reversible adiabatic process. So, in reversible adiabatic process, the ratio of final temperature to initial temperature is given by Pd by P1 whole power gamma minus 1 by gamma. So, let us say T1 is the inlet temperature of the gas turbine and P1 is the inlet pressure of the gas or pressure of the gas at the inlet of the turbine, and P2 is the gas pressure at the exit of the turbine. T2 is the gas temperature at the exit of the turbine. So here in the given data, a gas turbine is supplied with gas at 5 bar and 1000 Kelvin, that is P1 is equal to 5 bar and T1 is equal to 1000 Kelvin, and expands it adiabatically to 1 bar. So P2 is equal to 1 bar. So here we'll have to find out the here the mean specific heat at constant pressure and constant volume are Cp is equal to 1.0425 kilojoule per kg Kelvin and Cv is given by 0.7662 kilojoule per kg Kelvin. And we know that the power developed per kg of gas is given by mCp delta T. Let us say m is equal to 1 kg, so that it is equal to Cp delta T. So delta T is nothing but it is T1 minus T2. So here already we know T1 is a known value and we'll have to find out T2. So from this equation, the ratio of T2 by T1 is equal to P2 by P1 whole power gamma 1 by gamma. We can find out the T2. So that is equal to 653 Kelvin from that equation. So now P is equal to 1.0425 into 1000 minus 653, which gives a value of 361.7 kilowatts. So in the option, the right option is A. A is the right answer. A Carnot engine operating in a cyclic process between two temperature limits 500 Kelvin and 300 Kelvin with different working fluids as follow. Here two different working fluids are air and CO2, that is carbon dioxide. So out of these two, which Carnot cycle has maximum efficiency? So here both the fluids working in as working fluid in Carnot cycle. But we know that Carnot cycle is the thermal efficiency of a Carnot cycle is a function of temperature limits only, but not depends on the working fluids. So that the even though the Carnot cycle using different working fluids like carbon dioxide, air, or any other working fluid, so the efficiency is same for all types of fluid. So that here the right answer is D, same for both 1 and 2. In an experiment to determine dryness fraction of steam, the mass of water vapor separated was 1.2 kg in 5 minutes and mass of steam passed out in same time was 4.8 kg. The dryness fraction of the steam is, here the dryness fraction is given by the mass of steam to the total mass of water vapor mixture, that is the mass of water plus the mass of steam or water vapor. So here the mass of steam is given by 4.8 kg and here mass of water vapor is 1.2 plus 4.8, so it gives a value of 0.8, that is the steam dryness fraction is 80%. Type of question, assertion and reason. Here the assertion is the entropy of an isolated system always increases and becomes maximum at the state of equilibrium. Here the reason is entropy may decrease locally at some region within the system, but it must be compensated by a greater increase of entropy somewhere within the system. So in an isolated system, we know that the entropy always increases. That is the entropy of the total entropy always increases. So isolated system is nothing but we can take the universe is the best example. So the entropy of universe always increases. That is the sum of entropy within the system plus the entropy of entropy to the surroundings always increases. Of course, entropy may decrease locally at some region within the system, but it must be compensated by a greater increase of entropy somewhere within the system, isn't it? So, like this, the reason also correct because here entropy of universe increases, but not, but it doesn't mean that the entropy of system and entropy of the surroundings always increases. So, the entropy of an isolator always increases and the reason also right. So both A and R true and R is the correct explanation of A. In an NC code, M05 refers to, here the options are spindle on, spindle off, coolant on and coolant off. So here the right answer is spindle off. The surface roughness can be represented as, here the options are circles, squares, zigzag lines and triangles. The right answer is triangles. Inspiration effect in the casting results in, here the options are porous casting, porosity, inclusion and uniform strength. Here the right answer is porous casting. In a time series forecasting model, the demand for five time periods was 10, 13, 15, 18 and 22. A linear progression fit resulted in an equation f is equal to 6.9 plus 2.90, where f is the forecast for period t. The sum of absolute deviation, the sum of absolute deviations for the 5 periods is. So here absolute deviation is nothing but difference of the demand and forecast. So consider a table with the columns period, demand, forecast, where f is equal to 6.9 plus 2.90 and absolute deviation AD is given by D minus F. So now consider for the period of time first, second, third, fourth, fifth. Here demands are given as, for the first period it is 10, 13, 15, 18, 22. And forecast is for the first period just substitute t is equal to 1 here, so it gives a value of 9.8 and now substitute t is equal to 12.7, 15.6, 18.5, for the period 5 21.4. So now take the absolute deviation, that is difference between demand and forecast. It gives here it is 0.2, 0.3, 0.6 and for the fourth period 0.5 and for the fifth period 0.6. So the sum of absolute deviations is equal to 2.2. So in the option the right option is A. A is the right answer.